First, thank you everyone for coming in person and everyone online. This is our first event in person for 3 years. I've had to do this. Mary-Ann's fed off a bike, so she can't talk. She'll smile and bleed everywhere. My job today is to basically say welcome to the group. Please, if you can, join the HVAC group and hear what's going on. That's basically all we're doing now is pass over to Kate. Thank you very much, Kate, for being the host today, and look forward to a fabulous event.
Great, thanks, Phil. So welcome everyone to Hawley, London in the Western Transit. Great to see the breakout space being used for this kind of thing again. It's really good to see you all here. A bit of housekeeping, so and fire alarms that I'm aware of for this evening. So if the alarm does sound, please all go out the way that you all came in, through the main doors there. So we've got some great speakers who are going to speak today. We've got Susie Diamond, who works at Inkling, who's going to give us founded Inkling, possibly, not works for, who's going to give us a technical overview of the new Part O building regulation about overheating. We're then going to hear from Imogen, who works in the Hawley Sustainability Group, who's going to talk about the human aspects of overheating in a bit more detail. And then we're going to hear from Alasdair at Wilmot-Dixon, who's going to kind of give a bit more of a contractor perspective and what he's seeing in terms of installations on sites and the ways he thinks this might be implicated into MEP systems. So it's going to be a really good lineup. We're going to have a Q&A session at the end of all the talks. So I would ask people in the room, as you think of a question, I'm sure there'll be plenty of good ones, but try and just make a mental note of it or jot it down and save that till the end. People on the Teams call, you can kind of chat questions away in the chat box as you go, and we'll be monitoring those and we'll be feeding those to the speakers in the Q&A at the end. So we'll be picking questions up from you guys as well. I'm turning to look at the speaker as I'm addressing the Teams audience, which probably is not necessary. But great. So each talk's going to be about 10-15 minutes, and we'll try and kind of rattle through to leave a good chunk of time at the end for us to have a Q&A session and a bit of mingling and finish drinks and the nibbles. So without further ado, I'm going to hand over to Susie to kick us off. So have the clicker, Susie. Thank you very much.
Stand here, please, so me and that.
Can we make sure the clicker works?
Pressing the right arrow, yes.
Actually, there was 2 clickers. I'm just checking which one it is.
I'll press that one, see what happens. Both at once?
Yeah.
We did, yeah.
Might start to tap.
Oh, Chris Whitty in next slide, please.
I'll do the tapping. I need to.
Blue screen.
So close.
Because then I'm in. Yeah.
So just give us, give us some.
Yeah.
Yeah, so I'm Susie Diamond. I'm a partner at Inkling. We're a building physics consultancy. We're really good, small but beautifully formed. And I've been invited to talk about Part O. I've been doing quite a lot of work in the field of overheating prediction. I was one of the authors of CIBSE TM59 when it came out in 2017. And I've been working on a number of different guidance documents, including a tool for GHA, early stage overheating risk. Huge thanks. So yeah, this is us at Inkling. We do a range of services, predominantly dynamic thermal bonding. So that's our invested interest in all this. But having said that, I'm really invested in seeing Part O be a useful facility that will mean that new homes going forward have less overheating risk. That would be a great thing. But as we'll see how well that comes to pass. So Part O comes into force next month, middle of June. There are some transitional arrangements, but essentially anything that hasn't got planning yet is likely to need Part O assessment. It applies to all new homes, including care homes, boarding schools and student accommodation. Although I think to date most of the research into it has looked at homes, apartments, houses. It's aimed at reducing overheating risk. So that's the intent. It's very clearly stated as that's the objective of the document. And then that's the intent of the building regulation, and the approved document gives some guidance on how you might go about doing that. So I'll talk about the approved document. There are essentially 2 routes to compliance, plus a load of other requirements that you need to tick, regardless of which route you follow, but I'll cover the 2 routes as well. There's a simplified method, which to my mind is a spreadsheet. Other people might do it in other ways, but a spreadsheet seems the obvious choice. It is quicker and easier than the other, as we'll come to, dynamic thermal modelling method. It's more prescriptive. It sets sort of fixed targets based on where your unit is and whether it's cross-vent or how it's orientated. And the main focus is on glazing areas and free areas. Maximum limit glazing areas, minimum requirement for free areas from the windows. The alternative is the dynamic thermal modelling route, which follows CTM 59, so use dynamic modelling, TATR-IS, usually design builder. You do need the specialist modelling software and an experienced modeller to progress it for you, if you want yourself. It does offer a lot more flexibility, shading measures, different locations in the country, different design options can all be included, shading from surrounding buildings. So it can give you a better result. But yeah, that time involved. So just to cover some of the additional requirements that these apply whichever route you take. There is at least one acoustician in the audience, so correct me when I go wrong. There are requirements on noise at night. It's specifically at night in ADO. There may well be other planning conditions that would set limits on lying on open windows during the day, but this is only at night, so for bedrooms and what will disturb sleep. These decibel limits have been set. I'm not going to talk about how you go around measuring them because there are questions about that. But the point, as I understand it, is that these levels are likely to occur in quite a massive number of sites. So Apex Acoustics have estimated that around 30% of existing homes would exceed these limits. So it's quite a big number of sites. It's not like a few niche, very noisy environments. It's anywhere near a busy road or a train line or anything where there is noise. Again, we're waiting. I know the acousticians are working quite hard to produce some guidance on how you go about measuring those and fill in some of the gaps that the ADO leaves, but that will follow. It's not my area, so I'm not going to cover it too much detail, but be aware that they are these limits and there are implications. So when those limits are exceeded, you need to think about how you are going to mitigate overheating at night. So that might be, it may be possible if you're only just exceeding those noise levels to still use openable windows, but use them with the smaller openings. At nighttime overheating is less. You may get away with a reduced amount of free area. Provided you open windows wide during the day and crack them smaller open at night, that might be enough to reduce the noise coming into the targets. Alternatively, it may be that some kind of acoustically attenuated vent or other passive measures like screening, using balconies, split balustrades, or there are a number of measures that may be possible, but they usually have quite a small effect on reducing noise coming in, so they may not be enough if you're on a really noisy site. So the next step is mechanical ventilation, and what I understand from DLAC is that it would be acceptable to still model with the windows open during the day, but then use a mechanical solution at night, just for those nighttime hours when you're sleeping, provided that mechanical solution is quiet too. But if there are noise issues during the day as well, in planning set requirements on not using open windows, relying upon them during the day as well, you may well be looking at a mechanical cooling solution because it's really difficult to pass that, particularly in London. So just to, sorry, I'm using up too much time on that. So additional requirements. The other one to think about is security. If you're modelling windows as being open, you need to be, particularly on the ground floor, you need to make sure that it's secure when they're open and that burglars aren't going to climb in, or whoever else might climb in. So we'll hopefully, possibly see more options such as bars and grills and secure measures to make sure you can leave windows open but still get breeze through. So they need to be fixed and lockable. Protection from falling is another big one, and again applies whatever route you're following. There are now a minimum, I think it's 1100 sill height, which is quite high when you look at where that is on windows. Now you can have glazing below that, but it needs to be the openable panes needs to be 1100 sill height, or there needs to be some guarding measures before lower down. Again, that give you that 1100 something. The other thing is reach. So windows, if you have a wide window, you can't open it or allow the free area that you use in your calculations to be more than a 650 mil reach from the inside wall. So you can't fall out of the window trying to open or close the. That seems fairly sensible, but it's quite tricky to measure. So, simplified method. Not as simple as it sounds. You have to test every single unit. There's a lot of measurements you need to take. So the glazing area has to be measured and the free area has to be measured. Not the same thing because not all panes will open. And it's framing as well to be taken into account. So there, you have to go through that process. There are maximum limits on glazing areas and then minimum limits on free areas, and those are set based on where you are in the country. So if you're in a high risk location, which they define as London, essentially with bits of Manchester recommended that you include, or moderate risk, which is everywhere else in England. Whether the unit meets the criteria for cross ventilation, which is windows on opposite facades, so not a corner unit, not articulated unit, it has to be diametrically opposite facades in order to qualify as being cross ventilated. And the orientation affects the targets that you give, west facing being having the toughest targets, considered being the highest risk. And the floor area and the floor area of the bedrooms and the floor area. There's a lot of measurements you need to do. So brace yourselves, there are some flowcharts coming to help you navigate all that, but it's more of a challenge than it initially looks. The alternative is CIBSE TM59, appoint your modeller, get them to do it for you. In this case, you only have to do a sample of units, so you have to pick a sample that affects the worst case, which of the units are going to be at highest risk, more solar exposed, or straight up to window opening, for example. For anyone who isn't familiar with CIBSE TM59, it includes two criteria: adaptive thermal comfort test, which applies 24 hours, occupied rooms, and additional nighttime criteria that is tested only in bedrooms and is fixed 26-degree threshold. Again, aimed at making sure sleep is comfortable. Those criteria do change if you move to a predominantly mechanically ventilated scenario. So you can't use windows, opening windows for mitigation of overheating. They start to kick in their fixed criteria, which are much harder to pass in London. An outside web file doesn't help. The ADO, so Part O, has made some minor changes to how you model the window openings. Your modeler will understand all that. But the big difference is that ADO says you cannot use blinds or curtains in the model. That is going to be a problem in London, because it's quite usual to get to the point where that's the last bit that gets you over the past. So I'm interested to see how people get on with that and whether that results in more mechanical cooling going in as well. And then you get results for each room and work through and make sure that you'll pass all of your sample units. So which method you choose is up to you. There are benefits either way in terms of cost or time and flexibility. I think we'll see more evidence coming out as more people do these assessments about what works where, and including some of the ones that I'm working on myself for writing for the Future Home Club. Should be able to give you some more advice on where your best bet is. But in summary, am I in time stuff?
Okay. 15 minutes.
In summary, the simplified method is time consuming, not as simple to apply as it first looks. It also looks quite difficult to pass, particularly oddly in lower risk locations. particularly challenging. Our initial research suggests that results from simplified methods and the dynamic modelling method don't always correlate very well, particularly cooler parts of the country, cooler, windier parts of the country will sail through TM59, but flag up quite a lot of problems potentially if they've got those areas. In using simplified method, which seems, I think, is problematic. And yeah, TM59 is likely to be the default option in London and South East because it offers more flexibility, but also because Northerners are annoyed to use the simplified method. Because you can't big generous wide open windows, and that's the only way to get through it. Covered quite a lot in a reasonable amount of time, so sorry for the gabbling, but yes, that's me. There's a few resources out there if anyone needs more help. There's, yeah, including the guidance for the future home tab, which will be out by the 16th of June. So we've written that.
Brilliant. Thank you very much, Susie. Okay, so next we've got Imogen from Hoare, who's going to cover all the occupant impacts. I can ask you, Imogen, to try and vocalise towards the speaker as much as you can, because I think we're getting patchy audio for our Zoom people, Teams people. That would be great.
Right, thank you. So yes, I'm Imogen Christodoulou. I work with the sustainability team in Hoare, and I have a specialism and a passion for really putting occupants at the heart of everything we do, to think about health and well-being and how people will actually use spaces in reality. So yeah, I'm going to link to everything Susie said, but really think about designing for occupants. So yeah, talking a bit about what occupants' perspectives are on overheating, where those sources come from, what we might need to do design-wise, and yeah, hopefully challenging some of the ideas. So what I just wanted to bring up first, at the heart of everything we do within our sustainability team at Hoare, is really thinking about both human-centric design and also planet-conscious. So we're always trying to find that balance between making the space as best it is for the people that are going to use it, whilst also having as low environmental impact as possible. But yeah, where I come from, my opinion, occupants' health and well-being really must always come first, because they're the people that are going to be using those spaces. I'm sure you're obviously all aware why we're here. Overheating can kill. It causes a significant number of deaths every year, and that's going to increase. We've all seen news stories where we have these heat waves of excess number of deaths, and obviously as designers we want to do all we can to bring that down. That statistic there, that by 2050 the number of deaths from overheating will be the same as 4 times road traffic fatalities per year, which is a really shocking number. But then not just in that sort of mortality rate, overheating does have a big impact on heat. I'm sure everybody here has experienced horrible sleepless nights where it's just too hot and you don't really feel rested at all. So obviously everything we're doing is trying to reduce that. But who are we designing for and what do they want? At the heart of what we do, there's a diversity, a range of people that live in these spaces. We're designing homes that are for people with varying needs, different accessibility issues. We're designing homes that people are now using for workspaces. Before, traditionally, we would spend most of our week in offices or out in commercial spaces, whereas now we're spending a lot of time there, obviously working, we're raising family, and we want to feel safe and secure in the homes that we live in. So yeah, we have those new priorities, that work-life balance, that increasing use of our homes as offices. We're expecting more, we're understanding more what is detrimental for our health and how buildings impact that. And then what are the key challenges we've got at the moment? We're obviously facing rising temperatures. In recent months, we've seen a real growth in this rising energy prices, which is only going to increase over the next year. And obviously as well, that increased home working. So how we're designing homes is very different to how we would have designed homes a few years ago. In terms of what that means for overheating, there's all sorts of different sources of overheating. Obviously, solar gains, equipment that we put in the space, how people use it. And so currently, how do people manage overheating? I think we use regulations and we use guidance to manage and see how people use it, but actually how do people that buy those spaces that don't work within the industries that we do, don't have the knowledge that we do, operate to make sure that their space doesn't overheat. So I know I use a mixture of pulling blinds and curtains, opening windows, fans. Some people might start putting in air conditioning, and that's what the average person would expect to manage their overheating. Obviously, what can we do to make sure that they're managing that space properly? Early planning is key. We have there's the study that we did a few years ago with the UK GBC of all of the things that impact the health and well-being in households. I'm not going to go through each bit to keep it moving quickly, but so many of these elements feed into that part A. So sound, noise, comfort, sensors, bedrooms, windows, screening, quiet space, everything links into, basically. So in terms of mixed use developments, as Susie was talking about, we've got this mixed tension in terms of environmental impact. So we've got air quality issues, we've obviously got thermal comfort, we want to maximise as much daylight as we can, we want to minimise those noise constraints, not just at night, but also in the day, people spending more time there. So we really need to work early on to optimise that facade design. We need to combine various different assessments. We need to really be thinking about at an early stage, we have those noise assessments, we have those air quality, we use things like such as sonar analysis, so that when we come to designing our spaces, we've got all of the information, we can really design a space that is maximising everything it needs to. It's getting the right amount of daylight in whilst also not obviously increasing that overheating. And what that look like, we might see more increased, obviously, different types of shading. This is a building which is just across the road, but we've got those external louvers. Increased greening, which as studies have shown, can bring down temperatures of building, as well as obviously making the spaces look nicer. Thinking about windows, not just in terms of what the regulations say, but actually how people are going to use those windows and what people need out of that space. So two sort of contrasting pictures. The top one, the one on the left, you might look at and think that air gets blocked coming in through that window, but from a safety point of view, that minimises that risk of somebody coming in through the window. Whereas the bottom one, you'll get more airflow in, but obviously it might go against what those security requirements are. And then, yeah, thinking about challenging how we design spaces and what we expect to see out of houses and out of homes. External shading is not something that is common in this country, but is in countries around the world where they have higher temperatures. And so working to change that mindset of what we expect to see in houses and how houses might look by putting that external shading on to obviously comply with regulations and minimize that risk. And then really thinking about safety and security. We all want to feel safe in our homes. We all want to feel secure. It's one of the things that the guidance talks about, and obviously we see a lot of this ground floor bedrooms. Now, ground floor bedrooms may not be the best thing to have if you're trying to minimise overheating, because you've got to have that security of those windows and external locked louvers or shutters. But that isn't an option for all types of housing. There's accessibility issues where people would have to have ground floor dwellings and will have to have ground floor bedrooms. So therefore, we need to make sure that when we're designing, we're really thinking about all the people that will use that space. And then safety in terms of windows, we would start seeing that shift from having windows that open at the bottom and that you just have high level windows. I know, as I mentioned earlier, thinking about how people use that space, we design and we think we shouldn't have windows because windows are open because it's not a way to manage the overheating. But personally, and I'm sure many of you in the audience feel that when it is hot in the house, one of the first things you do, regardless of anything, is open that window. We design a lot of office buildings thinking about closed facades, but know that regardless of whether that's the best thing for the air quality within the space, people do actually have to open windows. From that psychological benefit, whether it has that obviously whether it's actually giving a benefit, is that perceived benefit that people really respond to. So yeah, occupants' health and well-being is key whenever we're designing properties and we're designing dwellings. We need to obviously comply with regulations and with guidance, but we really need to think about the people that are going to use that space, the knowledge they have. Part O guidance talks about building user guides. It's something that we see in environmental assessment methodologies, and we do them as almost a tick box, but they're going to be really crucial for making sure that people know what we're putting into a space, how they run that space, and then how basically they make it perform as we've designed it for them, so that they have that knowledge. Assuming that people will know what's best in the dwellings just won't work because people don't have that knowledge of mechanical systems of the overheating methodology. Energy prices are continuing to rise, and that is going to cause a huge difference in how people expect to use their spaces and how people expect, turn equipment on within there. We can't pretend like that's not happening. It's going to just keep going up. Early planning is crucial, getting all of the data so that we can make that informed decision early on. Really challenging what we think is normal design, what we expect to see out of houses, and look to other countries who have had warmer temperatures for many years and design homes that people live in, and taking that into what we do here. Making sure that all of that thinking is linked up, and then really thinking about what do occupants want versus what do they need, and making sure that we provide what occupants need in that space whilst also understanding exactly how they're using it. And then finally, I'm going to bring it back to whatever we do in our field of interest, we should always be thinking about how we can minimise that impact on the planet whilst optimising the space of the people that.
Thank you very much, Imogen. So now finally over to Alasdair from Dixon to take us through the contractor's perspective. Again, aim at the speaker, so that would be fantastic.
I will do my best to do that.
Thank you.
Good evening, everyone. Thanks very much for this opportunity to give a little bit of a view from the contractor's perspective on the matters of overheating. And what I'm going to try to do is complement what Susie and Imogen have talked about in terms of fabric-related and facade matters and occupant issues, by doing a little bit more focus on MEP and the implications of new regulations for that. I'm going to take you through some case studies, projects that are being delivered now, and I guess show the direction of travel for some of the issues that new regulations will throw up. So I'm sure everyone in the room, as conscious professionals and high quality CIBSE members, would be considering success in any given project to be the balance of all of the sometimes competing demands on particularly net zero carbon achievements that are demanded of us as designers and delivery teams, together with the important and vital issues of human success of the buildings that we're building. So the right solution, when we look at projects, my day job at the moment, Dixon, is to look at the performance of the buildings we deliver. We're a tier 1 construction contractor delivering mainly for social developments. And our success criteria are energy consumption, carbon emissions associated with that, cost of energy, and comfort and human factors, including acoustics. So those are a pretty decent set of success criteria. And I think the ones that we're all trying to intuitively balance across the projects that we're delivering. So I'll just take you through some of these projects and just food for thought, really, in terms of examples of what's happening on projects individually. The first one is a completed project, a low-density development that we did for Bristol City Council, a mixture of private and social houses. So on that particular approach, not particularly challenging in terms of net zero carbon or overheating risk and challenge. But I think a little bit of a direction of travel towards avoidance of fossil fuel and district heat networks, which were both excluded by the customers' focus on wanting to move towards, as far as we could, within the cost constraints towards a net zero carbon future, and with some consideration of future heating risk, as we'll see. So that particular services solution that was chosen for that approach was a shared loop ground source heat pump system from the Kenza manufacturer, very familiar with. So that system, pretty different in MEP terms from our project management team standpoint, integration of a lot of M&E services early on in construction projects, which gives us quite a big challenge. But the important part of this project really was that the customer, as well as all of these outcomes, wanted to focus on how these units performed, and that's essentially what we did. We collaborated, ourselves, the council, and supply chain partner Kenza, to study performance and use on a number of the homes. You'll see there examples of the flow and return temperatures from the ground loop and the delivery temperature to the heating system. So those of you are probably thinking, that's quite useful temperature from a cooling standpoint, and that was one of the things that we built in from a future-proofing standpoint, was that the heat pump systems had the future potential to use the ground loop as a low energy stroke passive, not really passive, but substantially lower energy than HVAC to achieve some kind of cooling mitigation. So that was part of Bristol's consideration. Just a little bit of some of the performance study results. We measured actual coefficients of performance. You'll see a variation around the target value in terms of MCS, largely down to balances of heating and hot water usage. You know, people are diverse; they use foams in different ways, and that's what you're seeing there. Limited amount of information on thermal comfort. That wasn't really the focus of the study, but that's something that we will be looking at in future projects, of which this is the first. This is currently in construction for the local authority customer in London. Very challenging urban site, very close to major highways, multi-storey residential, with probably all of the challenges that Part 1 would throw at us. And the solution for that project, which is currently in construction, is using Daikin ambient loop heat pump system. Other manufacturers are available. We have no links to any, completely agnostic in that regard. So I'd be interested to hear questions and experiences on others. Those systems, as you probably are aware, offer the possibility of active cooling and active heating and hot water generation. And that project did evolve quite substantially in moving from a gas and electricity-based system towards non-fossil fuel, which is an interesting direction of travel. That was the customer's political decision to do that at some substantial cost to them. So that's, you know, an interesting direction of travel, moving towards this kind of heat pump system being more normal than the past. And challenges, of course, whilst it's clever and combines heating and cooling, and that's great from a COP standpoint, it does result in a system that is really pretty complicated. A lot of kit on the roof, there's a lot of kit in apartments, and it's not very proven technology. And that's exactly the reason that we're doing some performance studies ourselves with our own resources to look at how well these systems really work out in actual terms, like we did with the system. Next couple of projects are two projects with the same customer, slightly contrasting approaches. One is a very sort of high noise, poor air quality site. One is less so, Whatmore. And there, it's resulted in two different services strategies. One which is the same as the first project, and one which is more a heating only conventional approach with heat pumps. And I think that the interesting challenge from our standpoint between those two systems is the degree to which adverse heat gains from a high temperature, medium temperature heat network supplying HRUs is going to contribute to overheating matters. Sure, everyone in the room's heard of horror stories of that in the past, and you know, that remains an issue with any kind of heat pump driven temperature system. So that's something that we're trying to focus on quite a lot. And again, trying to make sure that we capture the right balance of information and get some real world experience on how well these systems perform. A little plug for a great subsea document that ourselves and many other members in the room here contributed to, authored by Arab, which is focused specifically on heat pumps within the multi-residential sector, but considers a lot of the issues around overheating mitigation as well. So great document to use and reference. I've rattled through that in the right amount of time.
So perfect. Thank you very much. Oh, brilliant, fantastic.
I'm just going to put the microphone lower down.
Okay, great. Thanks, Ashley. So we are absolutely bang on time, which is great. So I might turn this projector off and ask all three of the speakers to kind of come and stand at the front, so we can kind of get into the Q&A section of the proceedings and kind of feel less like we're in a spotlight under the projector beam. So before I open it up to the kind of floor and the people on the Teams call, just want to say thank you very much for all the talks. They're all incredibly interesting. So an issue I think we've all been dealing with over the past few years, and this next step of seeing the building regulations come through and meaning we're going to be dealing with this on all our projects going forward is really interesting. I was interested, Imogen, to maybe hear a little bit more on your point about rising energy costs and how you feel that might change the way that things are kind of being managed by people in their home?
Yeah, so I think we have a real challenge at the moment with, obviously, we've experienced rising energy costs over the past months. People are trying to heat their homes, and we've seen a lot of news stories about people just turning off their heating because they simply can't afford energy bills. Now, obviously, as we move into warmer months and people experience those warm homes, I think we'll see the exact same issue with people not wanting to put fans on, and people, if they are in dwellings that did have active cooling in or had MVHR systems that they can switch. I think we'll see a lot more instances of people taking things into their own hands and turning off systems that are in there to help cool the space. And yeah, I think a big part of that is going to be that knowledge, so that people understand why those systems are in there, what they do, but also trying to passively design, obviously, how so that as much as possible we can reduce the reliance on systems to cool house. I think people will still want to open windows, will still pull blinds down because they're free to them, particularly in affordable housing. Yeah, I think it's
Okay, and so Susie, building on that, then it sounds like meeting part O is going to be a real challenge, particularly in London and the southeast, without those mechanical, more interventional methods. Is there a risk clients are going to say, well, if I can't use these windows, I'm just not going to pay for them because they're costing me money and I have to pay for all these other systems, so we're going to end up with a lot more sealed facades, do you think, and remove that choice for occupants?
I really hope not. And that, yeah, the approved document is keen that that isn't the outcome. But yes, I can see the risk there. And I think it is particularly difficult to demonstrate, and I completely agree that all the passive measures are by far the most powerful in terms of enabling home occupiers to have that control and those options. But in terms of us demonstrating compliance with this new regulation, particularly in London and in noisy, polluted, unsecure environments, is a real challenge, particularly because blinds are not an acceptable inclusion. And it's hard to know quite how that's going to play out at this point. I'm hopeful, but I'm also wary.
It's a question from a novice. Is that internal blinds only or external shading?
External shading is allowed.
Shading?
Yeah, no, external shading is allowed, but internal blinds and curtains are not. I mean, obviously you can put them in your house. There's no ban on them, but there's you can't include them in your modelling. With some good reasons, but actually I think most people would put up blinds in their curtains in their bedroom for privacy reasons alone, and then most people would pull them in sunny weather. So it's an argument there.
And so, Alasdair, it's really interesting that last case study you mentioned where you have the same client who's taking two very different approaches across one project, one of which is going to offer them the option to provide cooling using the same equipment, and another one where that option has kind of been removed.
Yeah, I rattled through the rationale there a little bit to expand on that slightly. The one with the site with cooling has a substantially more challenging target to meet from TM59 standard. Both are assessed under TM59, but the site constraints on the first one mean that the limitations are much greater. And that's one of the drivers. But yeah, the customer realizes that they haven't ended up with that. Two different solutions to roughly the same issue.
Yeah, I just wonder if we'll see more of those systems that can do two birds, one stone kind of approach moving forwards, but they come at a higher cost. And what does that mean for the rest of the project?
Not just a higher capital cost, but potentially a running cost.
Yeah, really interesting. Right, well, has anyone in the room got a question? Yes, you, sir.
Thank you very much. Draw on one of the points Imogen you made. I lived 3 years abroad in a climate of the sort we will be expecting, and the standard solution is cheaper to run, more intuitive for the occupants and what have you, and was often installed by the developer, was simply a ceiling mounted fan. They didn't need higher ceilings and what have you. So my question is actually for Susie. Does the modelling actually allow us to include evaporative cooling, which is effectively what the 2.5 degrees that you get off a fan, allow us that nice straightforward option?
Totally agree, but no.
Susie. So I'm just gonna repeat the question for the benefit of the people on the Teams call, just briefly. So the question is whether or not the modelling allows us to model the effect of ceiling fans, which are really an effective solution in areas of hotter climate. So Susie.
Yeah, and the point is, yes, they're a really, really good solution. I think anyone who's got them in their house would be grateful, and that sense of breeze is really valuable, particularly if you're in a single aspect unit that's struggling to get the cross ventilation through it. So I'm all for advocating that they go in, and it's really frustrating that we can't include the benefit in the modelling as it stands. But I know you've been campaigning for a while on this, and hopefully, yeah, we'll.
Is it complicated to model? It was felt to be too complicated to incorporate. What is the reason behind that? Maybe you can't say.
Well, it's to do with the physics being a bit complicated, but you could put in a rule of thumb that said, provided the fan meets certain specifications, then you can deliver approximately 2 degrees in terms of how you perceive temperature, and that can be really helpful, particularly at night. Yeah. So, and a lot of us put on a desk fan at night when it's hot, but you know, to have it built in would be even better.
Yeah.
So yeah, no, I totally agree, and I'd like to see more of them being put in.
Great. Have we got any questions from our Teams audience?
Yes, yeah, we do. So one of the questions that we've had, I think it's more into Alasdair, is are there any preliminary home occupant conceptions on the heat developments?
So that is how the occupants of the houses with these heat pump systems, which are, as you said, Alasdair, quite complicated, quite unusual in homes, how are they being perceived by the residents?
Okay. First project, which is finished and we've completed the study on, which uses ground source heat pump systems, so no cooling as such. But in technology terms, those work really well. Yeah, pretty proven technology and very reliable. No major O&M issues so far. On the future projects, jury's still out on those. That's exactly why we're studying. And we're currently working on how we structure that monitoring and that feedback, but very definitely will include feedback.
Do you know if your clients are planning on kind of providing a maintenance service themselves, or is that something they're expecting residents to take on?
Don't know at the moment. Not defined yet.
Yeah. Good questions.
Yeah, indeed. More questions.
Yeah. I'm just going to take another question in the room from the lady over there.
There is a cost threshold that they need to basically get, and we're dealing with this. I remember developers before and the answer very expensive in terms of cash. So just trying to understand the business case from a point of view of the developer. Bear in mind that the tax in London is already overpriced. So is this really justifying not to give people who are paying all that premium money the level of comfort they deserve, whether then they turn on the system or turn it off? That is another thing.
Yeah, sure. That's an interesting question. And actually, those last two developments that you saw were 100% social rental developments. So despite the fact that there's no market advantage, because it's not relevant in these cases to that functionality, the functionality is driven really by regulation and I think to some extent the social responsibility of the social developer as well.
Yeah.
In that case.
I guess clients won't have much of a choice anymore. If you need to comply with Part O, then that's one of the few solutions that might get you there.
In that scenario.
Yeah, in that scenario. Great. Yeah, question from the front.
A question on the presentation referencing the heating corridors district of common heating pipe.
Yeah.
There was a number of experience issue during the basic degree. Are you still seeing that lower temperature in your system?
So I'm just going to repeat again. So the question is whether or not we're seeing any issues with the ambient loop kind of heat pump systems in corridors as opposed to the older kind of high temperature district heating systems.
More medium temperature, I suppose.
Yeah, the ambient loop systems start out at 20 to 25 degrees, so essentially there's no heat in them. Well operated heat network systems that are efficient, that have low return temperatures and so on, and yeah, those risks are much smaller. But not all the district heat networks are well operated or well maintained or well managed. Unfortunately, I think the risk is always there with a normal temperature heat network of 60 degrees or 65 floor temperature or something. Then that is a high temperature substance that is at risk of overheating, contributing to overheating in the hardening block.
Part O does require you to check for that.
Yes, buildings that are even considering
They definitely are.
Higher temperature.
Definitely still an issue. Another question from Teams?
Yeah. So on the thermal simulations part, different criteria for opening windows based on room temperatures compared to 250. The question is there any circumstance where you ever use 259?
Okay, so this is whether or not anyone is still going to use TM59, given that the Part O regulation gives you different assessment criteria, particularly regarding openable windows. Definitely one for Susie.
That's a fair question, and the answer is probably that TM59 effectively becomes obsolete, apart from in the context of Part O assessments, which is all the more frustrating that those small changes weren't implemented via CIBSE and the TM59 update, because it means that we've got the advice in two separate places, which is confusing and could cause problems. But yeah, no, it's hard to see where you would use and well, the reason you might use them in the short term is for schemes that have already got planning and therefore are not liable for Part O for the foreseeable, but may fall under the GLA, for instance, or may have a planning requirement or a client requirement for overheating checks, and then you could use the original TM59, but a very within the next couple of years it's going to become Part O version.
So I think the person that asked that question is more informed about this than I am, because I hadn't picked up on this from the talk. So is that the difference between the simplified methodology versus the complex, or?
No, it's the difference between the TM59 that is required for Part O, which has some extra caveats about not using blinds, opening windows at particular threshold temperatures, how you treat windows at night. There's some very specific changes that aren't explained but are just required.
Okay, so it's like a TM59 plus.
Indeed.
Now, which could catch people out. Okay, really interesting. Okay, any more questions for me? Yes, sir.
Yeah, so Martin Walker, I'm the resident for Inkling. Two parts of the question. One that we've seen within Part O is there's a section where the guidance is understanding the intent is to not push cooling systems in with it. When we spoke to some building controls, they said that's it, no cooling, so there's no cooling solution. Is there guidance for building control and how far we push it past the systems? How far do we push back? And the second part of the question is on the internal blinds issue. We have seen some building control officers for an accepted thermal shutters as an approach. So my understanding the guidance was so there wasn't something that could be removed. So a fixed internal shutter they've seen has been a way that could comply. That means you don't have to do something to decide to market. I think that's the way forward.
Okay, so I'm just going to again summarise for everyone. I just don't want to isolate the people on the Teams call. Maybe they're here everything fine. But so part one is that the guidance seems to suggest that we shouldn't have to have cooling to pass, and there's a bit of a concern that building control officers are going to kind of think, well, you've got a cooling, so you've just not tried hard enough. Are they being given guidance on what can be done passively or what they should expect to see passively? And the second part is, are internal fixed shutters acceptable, whereas blinds may not be, but something that couldn't be removed and taken away, is that accepted under Part O?
Yeah, so two good questions. From what I understand, the Department for Levelling Up Housing and Communities are producing a set of FAQs that they're going to provide to building control to help them answer some of these questions. So there will be more guidance. They're not going to put it in the approved document, but they are going to provide this set of FAQs. And there's exactly the sort of questions that will be, hopefully we can push them in there as well. They stated quite clearly that cooling should be a last resort and passive measures first, but there's very little kind of meat around how that would be policed, or, I mean, there's very little to stop a developer saying, oh, I've tried everything and this is the way. And I don't think building control are going to have, I mean, it depends on the building control officer themselves and their approach and where in the country they are, probably, because in London, I think that's going to get accepted quite easily. You know, in Durham, people might go, what? Why can't you get away without cooling? So, and that's probably reasonable to a certain extent. In terms of shutters, that's an interesting one, and I will be raising that one because that's a really good question. And yeah, that's a really good question.
To be continued. Okay. I had a question, almost maybe a show of hands in the room, actually. So I have a project not too far from where we are right now, actually, where overheating was discussed. So I saw what you said, Susie, about the Part O guidance about sill height. You need to have the minimum 1.1 metre sill height. Actually, I had a contractor on a project say that they didn't think that was sufficient. This project had sill heights that were all that high, but they were saying, if you're expecting to leave a child asleep in a bedroom or a vulnerable adult asleep in a bedroom with a window open, who's to say they won't bring a chair or something over and climb out of that sill height? We don't think our clients should be accepting that. We want to raise this as a big risk. I don't know if anyone else in the room, a show of hands, has had that come up on projects. Yeah, a couple of people, but obviously.
Response.
Hmm.
The typical one quoting earlier is, are you doing the same with the stairwell balustrades?
Hmm.
Or are the kids able to kind of whatever? There needs to be a reality check.
Yeah, it's about finding that balance, but it was an interesting point I hadn't thought of before until the contractor brought that up.
No, it's a good question. DLAC is saying that the reason they've raised the sill heights is to alleviate the need for restrictors on windows, and they think that's safe at 1100 mils. But I quite agree that a chair or any kind of furniture in front could provide a mechanism. If you're 10 stories up, that's alarming. My view, personally, is that there are solutions to do with the design of windows that additional security grills, similar to a stair gate that you might put in if you've got toddlers and stairs, that could be inserted into a window to enable the window still to open, but with an additional level of security that can then just be fitted where you need it. So in the child's bedroom, and it doesn't need to be in every window in the house, but you might. It's an option that parents or anyone who's looking after someone for that whom that might be a risk can add on. Yeah. And that versatility, I think, what I'm hoping we'll see is much more generous window openings, so more panes that open everywhere, which I think will be really good. But with these additional functionalities that enable you to lock them securely or make sure people can't climb out or climb in. And I think that's a challenge to designers and window manufacturers to come up with these solutions, because it can't be rocket science. There must be.
I mean, Imogen, so that links back to what you were saying. I suppose it's about talking to the clients, understanding what they think their residents and their occupants are going to need and what works for them, putting them back at the heart of that
I think
conversation.
really understanding the type of occupants that are going to be in that space and being realistic with areas, you know, dwellings and types of properties we develop and we work on. You know, there's all sorts of different people in different areas. You know, you are going to have areas where you might have more families, and therefore you need to think about that. But then you have other areas where the dwellings, you know, you say that it's a 3-bedroom, it could be a family, but being realistic, you're never really going to have a family potentially living in that space. So yeah, definitely thinking about those differences, and then making sure that people understand and have that flexibility. put in perhaps those systems that are just in that bedroom, because that's now become a child's bedroom, and not have to have it there all the time. We've looked at the pictures of the like external. I personally like to see external like going into the ground. Like, oh, lovely.
Yeah.
That looks great. So yeah.
Okay, I think if we have one more from Teams and then one more from the room and then bring the event to a close, there's plenty of beers, I think, that still need drinking here, so people can kind of continue the conversation after. So Matt, have you got one more?
Yeah, so if building was supposed to last winter, is there a requirement to model thermally how buildings will be in like 2050?
Okay, so how are future climate scenarios captured in Part O, if at all, given expected lifespan of buildings?
Yeah, no, that question comes up quite a lot, and as it stands, it isn't included in. TM59 gave advice about looking a bit further ahead, just as a test, not necessarily to comply, but just to be forewarned. Part O doesn't require that, but it is quite onerous as it is. And the 2020 weather files that we're using go from 2020 up to 2050. So, they sound like they're already receding into the past, but actually they do intend to cover the next couple of decades. But it's a good point that 2050 is going to come quite soon, and most of the houses we're building now, hopefully, will still be lived in and occupied well through until 2080 and beyond. So, yes, it's a good question, but I didn't write this.
Okay, and then last one for the room. I'm going to go all the way back to Rob at the back there.
Actually, there's a part of the security solutions do exist. Hydro windows and security screens. So it's a very different style of window that doesn't exist. And plans and what. Certainly, and better. My question is, how much is looking at Part O solutions giving good ideas about existing overheating to current apartments that have
Okay, so Australian in the room has started by saying we should all be more Australian. I think that was my first takeaway. but then asking, does this guidance give people help in how they can overcome existing overheating issues in buildings? I don't know which of the panel feel that they can speak to that.
Just one small commentary back to the issue about heat networks. I think heat networks have two big black marks against them now, net zero carbon and overheating. So, personal view.
Yeah, so pushing
Maybe for
people,
another day.
pushing people away from that. Imogen, do you have any thoughts on that?
Yeah, I mean, I think it's really important. This is obviously looking at new properties, but we have a very old housing stock in this country with a lot of challenges that we can't do. I guess some of the benefits of it applying to new builds and not to old is that we can think more in older properties about the ceiling fans and some of the things you might not be able to use in the Part O regulation, things with windows. I live in an old Victorian terrace that I just had my windows changed last week to sliding sash windows with the locking, so that if there are children ever in the future living in the house, I can limit that. So I guess you have a little bit more flexibility in existing properties, types of systems in. But yeah, I think it's a really, really important and a big issue with both overheating and then also firstly in winter months with houses that aren't warm enough. What we do about that.
Susie?
There is, I know because I was helping write it with Julie Godfrey for the Good Homes Alliance, there's a retrofit tool guidance looking at existing homes and predicting the sort of degree of overheating risk and taking you through what kind of mitigations might be appropriate in different contexts. It's out in a kind of beta version at the moment. It's been piloted over the summer, and we're awaiting feedback before we finalise it. But it's freely available from the Good Homes Alliance website, so that might be somewhere to have a look, and that just kind of frames up where all the different factors that affect overheating risk and what might be done about them.
Great. Okay, well, I think with that, we'll kind of bring proceedings to a close. I think if anyone's got any further questions, you can find our speakers in the room or maybe on Teamster. I think the presentations that have been shared here today will be made available on the website for people to access. And I'm sure there'll be kind of means to kind of follow up with questions with our presenters should you need. But thanks very much again to our speakers, and thanks everyone for coming. Thank you.
So one last point, actually, what we used to do in the olden days, when we could speak to people, we'd actually have like a register at the front desk. Apologies for getting that, because normally you get a CPD certificate. So if you actually like to actually get one after the event, come and see me. I'll make some notes on the iPad, on the laptop, to make sure you get it afterwards. And I'd like to thank Hoare for hosting tonight. Your alcohol's always amazing. So I always like coming here. Thank you very much for doing it. It's been great. A few teething problems, but thank you everyone for coming. It's been a great event. I think I counted 50 people here tonight, which is fantastic. So thank you for coming. Thank you very much. Thank you.
Well, text.
Well.